Hi guys, and welcome to the Physical Science Year 8 iTunes U course. This is Activity 6, where we're going to be looking at how do we calculate the energy in food. Now, in order to get a gist as to how we're going to do this practical, what I'd like you to do is to make sure that you've watched the practical video, which I've put up next to this, this video, which will show you exactly the practical process which goes on. The reason I've separated the videos is so that not to make the video too long with the download. Okay, so what we've done is in that practical we were burning up a tiny teddy. Now you could use a variety of different foods. Now in the results that I've gathered here are going to be using two different types of foods. That's peanuts and Cheerios. Now in all of this I haven't taken into account anything to do with mass of the foods, and that, as I said in the practical video, is something that you need to take into account when you're doing the practical. So but for this level we're not going to bother with that, so we're just going to be looking at the differences between the energy types. So what you can see here is we've got two tables. We've got one for peanuts in yellow and we've got one for Cheerios, which is in green. Now we've got a starting temperature and a finish temperature for each test that we did, and we did 3 tests for each type of food, and from that we're going to calculate an average. This way we're not saying that one particular peanut happened to have more energy than something else. We're working on an overall. Now obviously 3 is all the time we had for it was the number that we had time for, although it would be important that you do, if you wanted a really good test, you do this many times. Now what we now need to do with this data is then to work out what the temperature difference is in degrees C. So in order to do that we need to take the starting temperature away from the finished temperature. So I do that for the peanuts. The first one is 78 minus 24, 83 minus 23, and 79 minus 24, and these are the values that we get. And then obviously for the Cheerios, the finished temperature minus the start temperature is 53 minus 24, 56 minus 24, and 52 minus 25, and those are the values that we get. Okay, so I've now calculated the temperature difference. What I now need to do is to work out what the average temperature difference is over the 3 different tests. And to calculate the average temperature difference, I use the formula which is in the red box. I add together all the temperature differences for each food, and then I divide by the number of differences. So for peanuts, what I would do, I would add the different temperature differences together, so that's 54 plus 60 plus 55, hit the equals on my calculator, and then I would then divide it by the number of temperature differences that there were, and there are 3. So I would do 54 plus 60 plus 55 divided by 3, and I come out with the average temperature difference of 56 degrees C. So let's do the same for the Cheerios. The average temperature difference will be 29 plus 32 plus 27, hit the equals, and then divide by the total number of temperature differences, which is 3, and I end up with 29 degrees C. So I've got 2 different temperature rises, 56 degrees C for peanuts and 29 degrees C for the Cheerios. Okay, so now I've got my temperature differences. I now need to convert it into energy. So how do I do that? Well, in science we've got a constant which basically states that 4.2 joules raises 1 milliliter of water by 1 degree C. Now, we didn't have 1 milliliter of water, and we didn't raise the temperature 1 degree C. But what we need to understand is for every ml of water, if I want to raise it by 1 degree, I'm going to need 4.2 joules of energy. So to raise 1 ml of water 2 degrees will take 8.4 joules of energy. 3 degrees, I would then add another 4.2, and so forth and so on. Okay, now in my practical you will have noticed that I had 10 ml of water. So I need to multiply this value for energy by 10. Okay, so as a result it's going to take, because of 10 ml of water, it's going to take 42 joules of energy to raise the temperature 1 degree C. So that's taken into account the volume of the water. So I multiplied 4.2 by the volume of water, which is 10, to get 4.2 joules. And I now know that 4.2 joules of energy raises the temperature 1 degree C. So all I now need to do is to multiply the temperature difference by 4.2. So to calculate the energy for each food, it's 4.2 joules times the average temperature difference. So for the peanut, it's 4.2 times 56, which gives me 2,352 joules. For the Cheerios, it's 42 times 29, which was the temperature difference, which is 1,218 joules. Now, when I compare these two energies together, I will see that peanuts will have more energy than Cheerios. However, as you may say, there is not, the weight of a peanut is a lot bigger than the weight of the Cheerios. So what I can then do is divide it by the mass, and that will actually give me the weight per gram. And that is a useful exercise for later on. But for now, all we need to do is to be able to do a comparison between those energies that we find in each of the foods. Now, obviously, different foods are going to have different energies depending on the type of things that they're made out of. If you've got a lot of oil or fat in there, they're going to burn for longer because they're more energy producing foods. So this simple method that we've done in the lab can be used in a variety of different ways with a variety of different foods, and some good results can be calculated. Okay, so I hope you found that useful. There will be some more exercises looking at energy and using those energy values in this unit, so check those out, have a go at them and see how you do. Thank you for watching.